Hey guys, welcome back to my project. This is Eric. In this video, we will complete the Firebase client for ESP32. Proceed with this project using the Firebase library available for ESP32 or ESP8266. Easily create a Firebase client and easily store and read data. Firebase is widely used in mobile applications as well as IoT devices. If your project is a service that requires databases and servers, you can configure it more quickly and easily using many features of Firebase. I hope this project will help yours. Okay then, let's get started. Let's add the Firebase library. There is a great library for Firebase. It's Firebase Arduino client library for ESP8266 and ESP32 by Mobist. When I do projects with Firebase, I already use his library. It works great. The version I'm using is 2.3.7. If you have the latest version available, please try the new one first. There may be new updates. Add the Firebase ESP client header file to the network header. Making a Firebase init function in the private and Firestore data update function in the public. Let me create a couple of member variables for Firebase. Firebase data object. This is including all data for cloud, Firestore, as well as real-time DB and lots of functions of session control. Firebase auth object. It supports what is required for Firebase authentication. Firebase config object. It's about configuring the Firebase, so we can use it to put the API key and callback functions. There are keys we need to access Firestore. API key, Firebase project ID, user email, and password. I will get it from the project settings in the Firebase later. Let's configure the Firebase initialization first. Put the API key into the Firebase config. In Earth, put the email and password. We can connect to Firebase with Firebase begin function after preparing everything it needs. After the connection, we must be able to write data to the cloud Firestore. I'll finish this part as well. First, check that the Wi-Fi is connected and the Firebase is ready. I'm gonna put this device in my child's room, so let me make a path of the data like this. We can create content easily with the Firebase JSON. After fields, put the desired field name and define the data type. Then you can put in the actual data. This is a basic rule of data content, so you have to write it this way. Let's create a document for the first time. To create a document, use a method called Firebase Firestore create document. As parameters, reference of the Firebase data object, Firebase project ID, database ID, default is empty, document path, and the raw data of the content. Returns true if the document is created without any problems, otherwise false. If there is a problem, print out the reason for the error to see what the problem is. I will copy and paste the required values from the Firebase settings page. Press the key icon to display a pop-up menu and select project settings. First select web API key and copy it, paste it into API key. The next one is the project ID. Also select and copy all and then paste it into the Firebase project ID. User email and password use what we created earlier in this project. If you forgot it, you can delete it and make a new one. Unfortunately, it doesn't support editing the user email and password. We now need to call the member function Firebase init after obtaining local IP after connecting to Wi-Fi, but the problem is callback functions are not member functions in the network class. So to invoke member functions from auto member, we need a reference that points to itself. So let me create the static instance for this network class. Let this instance point to itself when the object is created. So we can access member functions and variables through this instance. Calls the Firebase init function after the local IP is obtained. Good. Let me build it now to check if it's fine. Oh gosh, there's a typo. I missed the C in the Firebase project ID. Sorry about that. Okay, so far so good. Let's go back to the main and add the network. Let me include the network header. I will create a function called the init network, just as I created the display initialization function. Create one object from the network class and call init Wi-Fi function. This makes the Wi-Fi operate internally. Firebase will be ready for use after Wi-Fi connection, and we will send data via the Firestore data update function. Go to the get temperature function and call the Firestore data update function of the network. I didn't add an init network function in the setup, almost done. I forgot to add the Firebase token status callback function. Let me add it quickly. It's the same as what we did for Wi-Fi status. With this, you can see what the current Firebase status is like. If there is a problem, you can get what the problem is. To do this, add the as-on token helper header file. All of them are included in Firebase ESP client but must be additionally included. Let me finish this callback function. For now, I just print out the token status. We will add the code for the icon indicator later. Finally, simply specify this callback function in Firebase config. That's it. Okay, let me build and see the result. DHT initialized, temp test group started, Wi-Fi connected, and then get the local IP. Firebase initialized, is getting token status. Now Firebase is ready to use. Oh no, there's a stack canary watch point triggered temp task. I know what this problem is. This project works based on task. This problem is caused by the insufficient stack size assigned to the temp task. I will return to the main and change the size of this stack. Here, it's set to 4,000 words. The stack size is specified in words, not bytes. Let me increase it to 10,000 words. Let's run this project again. The current temperature value has been updated and the data also has been updated to Firestore. In the console, we see there is no problem and it's okay. Let's reload the Firebase page again. House, room, humidity, temperature. The Firebase collection document was created. In the console log, it said that it already exists when it tries to create it again. Smart boy. It seems necessary to modify the code so that it can be updated. Let's go back to the code. Before it creates a document, it tries to patch it first. If there is no document, the document patch is not possible. Only in this case, it creates a document so it can work normally. It's a pretty simple way. For patches, you must include the field name of the data to be updated at the end. This is all. Let me run and check the result. The newly updated data can be seen changing color and changing values too. It works very well. If the readings obtained from the sensor are the same as the saved data, the patch is not achieved. Yeah, it makes sense. Next, let's learn how to update a status icon on the screen. Stay tuned. Thanks for watching. See you soon.